All right, so now we're going to get to vertical dilations and horizontal dilations, or vertical stretches and compressions and horizontal stretches and compressions. Vertical isn't so bad. Horizontal is always very tricky, so make sure you're paying really close attention to this, okay? So for vertical dilation, if your original function is y equals f of x, your new function becomes y equals, when you stretch it, it becomes higher or lower, so you're just stretching it vertically this way. When you're compressing it, what you're doing is you are smushing it down so that it is a lot shorter. So this is making it taller, this is making it shorter. Okay, so if that's the case, then what you're doing is you're just multiplying the a value by a scale factor, just like you did with dilations when you were in elementary school. So the y value is getting multiplied by your scale factor, which is a. So a right here is equal to your scale factor. Okay, so now if the absolute value of a, and we're saying the absolute value of a because we want this value to be positive. If it's negative, it's just going to tell us to do some type of reflection, right? But if it's positive, the absolute value of a, if it's greater than 1, then it's going to stretch it. It's going to make it taller. Because if, for example, the scale factor is 2, it's twice as tall. If the scale factor is 5, it's 5 times as tall. So you're stretching it with a scale factor of 5. If it's shorter, then it has to get smaller. So it has to be a value that's less than 1 but greater than 0 because we're talking about the absolute value. So 0 is less than a is less than 1. So the absolute value of a has to be between 0 and 1. And I know this might seem a little bit strange, but I will explain this to you a little bit more in the 2 examples that are coming up. Okay? So the vertical dilation isn't that bad. It's the horizontal one that gets really tricky. So right here, if y equals f of x, then when you do a horizontal dilation, it would be y equals f of kx. And remember, since it's horizontal, it has to affect the x because x is horizontal. And if you remember, when we did shifts, it's always going to be the opposite direction. You do the inverse value right here. So if it's -3, we go to the right 3. If it's +3, we go to the left 3. Same thing we have to do for our dilations right here, except we're not going to, it's not about positives and negatives because now we're talking about multiplication. We need to do the reciprocal because that's the inverse of multiplication. So right here, 1 over k would equal our scale factor. Okay, so again, it's going to be a stretch if 1 over k, the absolute value of 1 over k is greater than 1, and it's going to be a compression if the absolute value of 1 over k is between 0 and 1. Now a stretch will stretch it out horizontally, so it's going to get wider because this is a horizontal dilation, remember? And if we do a horizontal compression, it's going to get thinner. Okay, so let's apply this to questions 9 and 10. Okay, so questions 9 and 10 ask us to consider the graph of f of x below. Before I do anything at all, the thing that's really going to help me out the most is to create a table of values to indicate what x and f of x are, or what my x value is going to be and my corresponding y value. So when x is -3, I can look up here and see that my corresponding y value is at +3. And my graph on the left side is exactly the same as my graph on the right side, okay? When x is -2, my y value is 2. When x is -1 here, my y value is +3. When x is 0 here, my y value is 1. When x is 1/2 here, or 0.5 here, my y value is at 0. When x is right here at 2, my y value is at -4. And lastly, this last coordinate says that when x is 4, the corresponding y value is 0. And remember, f of x is the same thing as y. All right. So now that we've established that, let's take a look at what this says to do right here. It says to graph g of x equals 2 times f of x. So if you notice, it's just saying g of x is equal to 2 times y. So in question number 9, when I have g of x equals 2 f of x, all it's telling me to do is multiply all of my y values by 2. Okay? But it doesn't say anything about my x values here, so my x values will stay the same. So if you notice right here, my first coordinate is -3, 3. My x value stays at -3, but my y value gets multiplied by 2. So this 3 becomes a 6. So my new coordinate would be -3, 6. So I'd go to -3, and then I would go up to 6 right here, and this is going to be my new y value. This is my new coordinate. Now the next one, the -2 stays the same, but I multiply my y value by 2, so I get 4. So I'd go to -2, 4, and that's where my point is right here. So if you notice, what's happening is it's staying in the same spot on my x, but my y values are getting twice as tall. And remember, if a is greater than 1, then it's getting taller. Okay? Next one, -1 stays the same because it's x, but y gets multiplied by 2. So I go to -1, 6, and that's where my coordinate's going to be right there. Here, x stays the same at 0, but y gets multiplied by 2. So 1 times 2 is 2, so I go to 0, 2. Here, x stays the same, but y gets multiplied by 2, but luckily 0 times 2 is still 0, so this actually stays the same right here. Okay? Next one, the x stays the same again, 2 stays 2. -4 times 2 is -8, so I get -8 right here. So I go to 2, -8, and I have my point down there. Okay, and lastly, this 0 times 2 is simply 0, so this is where my graph is going to be right here. So when I connect my dots, I can see that my graph has the same shape, but it's just stretched out vertically. It's become a lot taller, both in the positive direction as well as in the negative direction. Okay, so now lastly, in question number 9, oh, sorry, it says to describe each transformation. So we can say that this is a, sorry about that, we can say that this is a vertical stretch. Okay? So now, h of x, the next thing that we see here is h of x is equal to 0.5 times x, or 0.5 times f of x. So what this is saying is 0.5 times y. So I multiply my y values by 1/2, or by 0.5. So multiply y by 0.5. So here, my x stays the same, multiply y by 0.5, and I get 1.5. So I go to -3, 1.5, and here's my, my value there. -2, my x value stays the same, multiply 2 by 0.5, and I get 1, so I get -2, 1. Multiply 3 by 0.5, and I get 1.5 again, so -1, 1.5 is right here. Multiply this 1 by 0.5, and I get 0.5. 0 stays the same, so I get 0, 1.5. So if you notice right here, what's happening is I am compressing my graph. I'm making it shorter. 0 times 0.5 is just 0, so it stays right here. -4 times 0.5, or -4 times 1/2 is 2, so it gets shorter in the negative direction as well. It gets closer to the x-axis. And then 0 times 0.5 is 0, so this point right here stays the same. Remember, again, all my x values are staying the same because nothing's happening to them. So when I connect my dots, I end up getting my graph looking like this. So this right here I can say is a vertical compression. Alright, this is the hardest part of the entire video, so pay extra close attention right here. So number 10, consider the graph of f of x below. We already considered it. We got our list of values. And the first thing we need to do is graph a of x equals f of 2x. So this time, we'll write a of x equals f of 2x. This time it's the x that's changing, so it's going to be horizontal. So if you notice right here, and I shouldn't have erased this, but we'll write this down, that 1 over k is our scale factor here. Of kx here, we're going to say that k equals 2, which means that our scale factor is equal to 1 over 2. And what we need to do is multiply our x values by 1 over 2. So we're going to multiply x by 1/2, which means that our y values this time are going to be the ones that stay the same. So when I multiply 1/2 by -3, I end up getting -1.5. So what this is saying is my x value is -1.5, but my y value is still at 3. So I can go to -1.5, 3, and that's the first coordinate that I end up getting. Here, when I multiply -2 by 1/2, I end up getting -1. So my x value is -1, but my y value stays at 2. Okay, here multiply -1 by 1/2, I get -1/2. So my x value is -1/2 and my y value is 3. Okay, here multiply your 0 by 1/2, it stays 0. So it's going to be an x value of 0 and my y value stays the same at 1. Here multiply 0.5 by 1/2. Sorry, that should be a multiplication sign. What 0.5 times 1/2? 1/2 of 1/2 is 1/4. So I'm going to go to about 1/4 and 0, and this is where my graph is, or my point on my graph is going to be. Okay. 2 more. Multiply 2 by 1/2, I get 1. So I end up at 1, -4. My y value stays the same. Here, multiply 4 by 1/2, and I end up getting 2. So I've got 2, 0. Again, my y value here stays the same. So if you notice right here, this time it's getting smushed horizontally. It's getting thinner. So my graph was originally wider, now it's getting thinner. And that's because we have a compression, because you're multiplying by 1/2. 1/2 is between 0 and 1. So we can say that this right here is a, close, cancel that, sorry, we're going to say this here is a horizontal compression. Okay, all right, one more to go. Our last one that we have here is b of x. And this time my b of x is equal to f of 0.5 times x. So here, k is equal to 0.5, so my scale factor is 1 over 0.5. And when I divide by 1 into halves, I end up getting 2 halves. So 1 divided by 0.5 is 2. So that means that what I need to do is multiply. We're going to write ourselves a note right here, that we are going to multiply x by 2. Okay, so I'm going to go ahead and erase what I have here, and I'm going to multiply my x's by 2, but my y, my f right here, stays the same. So when I multiply -3 by 2, I get -6. So right here, my new coordinate is going to be -6, 3, because my y value stays the same. Multiply -2 by 2, I get -4. So my new coordinate is going to be -4, 2. Y value stays the same. Multiply -1 by 2, I get -2. So -2 corresponds with my 3, so I put my coordinate at -2, 3. Multiply 0 by 2, I get 0, so I end up at 0, 1. It stays the same here. Multiply 0.5 by 2, I get 1, so I've got 1, 0 right here. Multiply 2 by 2, and I get 4, so my new coordinate would be 4, -4. Again, your y value stays the same. And then lastly, I'm going to multiply 4 by 2, and I end up getting 8. So I've got a coordinate at 8, 0. It's a little bit off my graph, but I've got the right idea. So this blue function right here is going to be my b of x. And I apologize, everyone. You need to make sure that you actually label each graph. So make sure you go through and do that right now for me, please. So we will call this b of x right here, and this pink one right here is a of x. And then on this side over here, the green one was g of x right here, and the purple one was h of x. Okay? All right. So what's our description right here? We're going to say that this time what happened is my graph got wider, right? So the graph actually got stretched horizontally, and that's because my scale factor, my 1 over k, is bigger than 1. So we're going to say that this is a horizontal stretch. All right, make sure you come with questions from the video if you need clarification on anything next time I see you in class. And I will talk to you soon. Bye.